Check out this ESP32 design for a servo motor controller. Now this is pretty straightforward as far as schematics go, and you can see here that most of these circuits are directly from the datasheet as the application circuit. One thing I do see here is that on these servo motors, you have them connected to 5 volts power, but they could run as low as 3.3 volts power. So maybe this is an opportunity to miniaturize your system a little bit, and you could bypass this 5 volt regulator. If you do bypass that 5 volt regulator, you're then going to be stepping down from 7.4 volts down to 3.3 volts. And of course, you're going to want to swap out this AMS 1117 regulator for a buck converter. I noticed you're bringing in data from this USB micro B connector. Nothing wrong with using micro B, but I will say that everything is going USB-C these days, so consider swapping this out for a USB-C connector. There are plenty of application examples online that can help you get this into your schematics. In your PCB layout, you do have this at only 2 layers, which in this case is fine given the density of routing that you have in this design. And even your USB routing looks pretty good considering how tight all the spacing is. But one thing I do notice is here on your ESP32 module, you can see here that you don't have any ground cutout below the antenna region, and you do need to have that ground cutout in this design. The other thing I'm seeing here is this very odd arrangement of all of these rows of vias, and I don't really know what their purpose is or why you have them, so you really don't need them. Next, down here by your connections to your servo motors, you do have a cap right here next to these headers to supply all of the stable 5 volt power, which is good. You do want to place it right there, but you have this semicircular ring of vias around the ground connection on this capacitor. You don't need those vias. They're not going to do anything. You already have that through-hole connection down to the ground plane on the next layer. If you're worried about inductance on this connection from this cap, you should swap out that cap for a large ceramic cap. Then you are not going to need a through-hole connection that has large inductance from those pins coming off the capacitor. And finally, looking over here at your 3.3 volt regulator. Here you have this line of vias along the edge of the 3.3 volt regulator, and frankly, they don't do anything. That AMS 1117 is not a switching regulator, so you really don't need to worry about using any kind of vias for shielding, so you can just delete those. If you want to make sure that you have low impedance ground connections everywhere, just use a stitching via tool like the stitching via tool in Ultium Designer. That's going to automatically place stitching vias around your design, and then you won't have to worry about creating these via walls like you've done here in this layout. Want me to do a deep dive of your ESP32 design? Find me on LinkedIn and send me a message with your design files.